Hello. So for today we are going to solve this example. Show that the equation ln y is equal to a e to the x plus b e to the negative x is a solution to the differential equation y prime prime minus y squared ln y is equal to y prime quantity squared. So basically we are trying to prove that this non-derivative equation is a solution to this differential equation. We're trying to find out whether if the derivatives of this differential equation are taken out, one of the forms of those non-derivative equation will be this one. So our first step would be to differentiate this non-derivative equation, but for how many times? So the hint would be the number of your arbitrary constants in your general solution will dictate how many times you are going to differentiate this equation. So for this example, since we have two arbitrary constants, then we will differentiate this equation twice. So after we differentiate, we are going to substitute those derivatives to this differential equation. We're going to substitute and we're going to find out if we can obtain an identical equation. And if that will happen, then we have proven that this equation is a solution to this equation. So let's start. We have here ln y is equal to a e to the x be. So I must assume that you have recalled all the differentiation rules and the integration rules before you take this subject. Okay, so let's differentiate this equation. The derivative of ln y would be 1 over y times y prime is equal to the derivative of a e to the x. So the derivative of e to the x would be e to the x dx. So this would be a e to the x dx. That would be times derivative of x is 1 plus b e to the negative x, and the derivative of negative x is negative 1. So multiplying both sides by y, we will get a y prime which is equal to y times a e to the x minus b e to the negative x. And this would be our equation 1. We are going to substitute this to the differential equation given on the problem. Now we have solved for the derivative ones. We are going to solve for the next derivative. So this one, this equation 1, we will again differentiate. Now, as you can see here, this is a multiplication of y and these functions, or this expression. So you must have recalled the product rule for differentiation. Okay, that would be, what would be the formula for that one? derivative of uv is equal to udv plus vdu, right? So you must have recalled for that one. So let's continue. Y prime, derivative of y prime would be y prime prime, and the derivative of this one will be udv. So y times the derivative of this one, and that would be ae to the x times 1 minus be to the negative x times negative 1 plus vdu. So plus vdu. Our v is ae to the x minus be to the x v du. So times the derivative of y, so that is y prime. So fixing this, you would have y prime prime equals y ae to the x plus be to the negative x plus y prime ae to the x minus be to the negative x. And this is our equation 2. Okay, so we now have equation 1 and equation 2, y prime and y prime prime. Both of these equations we are going to substitute to the general or to the differential equation given on the problem. So our original equation, this one, let's try to copy that. Okay, so let's substitute. This would be y. And what is our y prime prime? Our y prime prime would be this one. Okay, so this would be y times ae to the x plus be to the negative x. Okay. Oh, plus y prime ae to the x, minus be to the negative x. Oh, I was wrong with this one. So this must be parentheses. Okay, so this is the y prime prime, this one that we have substituted this variable. So let's continue. Minus y squared. And what is our L and y? Our L and y is this one. We have here y squared L and y. So this would be ae to the x plus be to the negative x is equal to y prime squared. What is our y prime? We have here equation 1. This one. That is our y prime. So this would be y ae to the x minus be to the negative x, and that is our y prime. Says in our differential equation we are going to square that one. So let's simplify. Okay, so we have to distribute this one to this. That will become y squared ae to the x plus be to the negative x plus y times this one. That would be, oh, we have forgotten to substitute the y prime on this one. Let's just do that now. So y times y prime, and our y prime is what is our y prime? Here we have this. That is y times ae to the x minus be to the negative x. So this is our y prime, and we have also to copy this one. Okay, so this would be y times y prime, so y times y prime times this one minus be to the negative x. So we are done with this part. Now let's proceed this part. So minus y squared ae to the x plus be to the negative x is equal to, okay, so let's distribute. This would be y squared times ae to the x minus be to the negative x. So bear with us. You can finish this. So as you can see, there is something similar here. This one, the y squared e to the x, ae to the x, this expression, and this one. So we can cancel out. Okay, oops. And this one. Okay. So we only have this one, so let us multiply that. That would be y squared, y times 1y squared, and this expression, they are the same. Ae to the x, they are the same, multiplied twice, that would be squared. And now we have proven so check. We have proven that this differential equation, that equation is a solution to this differential equation, because we have resulted in an identity equation. So thank you.